exploring old electrical wiring systems, particularly those found in buildings from the 1920s, requires a look at resources that document the standards and practices of that era. BX cable, also known as armored cable, was a common wiring method during this period. To gain a comprehensive understanding, here are several resources to consider. Firstly, textbooks can provide valuable insights. Residential Construction Academy Electrical Principles by Stephen L. Harriman includes a chapter, specifically Chapter 26, dedicated to knob and tube and non-metallic sheath cables. Secondly, Residential Wiring, a Practical Guide to Code Requirements by Robert J. Higgins features a chapter, Chapter 21, that focuses on knob and tube wiring. Thirdly, Agley's Electrical References by George V. Hartwell has a section, Section 29, covering residential and commercial wiring. These books can provide foundational knowledge on wiring methods prevalent during the early 20th century. In addition to textbooks, several websites offer information on obsolete electrical wiring and relevant historical codes. The National Electrical Code Handbook, accessible through the National Fire Protection Association or NFPA website at NFPA.org. Codes and Standards. All codes and standards. List of codes and standards. Detail ? Code equals 70 is a crucial resource for understanding the evolution of electrical codes. This handbook provides context for the standards that were in place during the 1920s and how they have changed over time. The Obsolete Electrical Wiring page on the National Association of Certified Home Inspectors or NACHI.org website, specifically NACHI.org Obsolete Electrical Wiring / offers specific details about outdated wiring methods and their potential hazards. For direct access to historical codes, the National Electrical Safety Code 1924, available through Hathitrust.org at Babel. Hathitrust.org CGI PT ID equals PSD 96,367,328 and view equals 1UP and sec equals 9 provide a primary source document outlining the electrical safety regulations in force at the time. The Vintage Electrical System Safety resource on Safewires.com, available at Safewires.com. Resources Vintage Electrical System Safety / addresses the safety concerns associated with older electrical systems. This is important because wiring systems age and degrade, posing potential risks if not properly maintained or updated. The BX Armored Cable page on Retroinnovation.com, specifically Retroinnovation.com 2012-619 BX Armored Cable / offers detailed information on BX cable, including its construction, installation practices, and common issues. These resources provide a multifaceted understanding of obsolete wiring systems. Furthermore, explore additional resources that offer insights into electrical code changes and incident analyses. Electrical code changes from 1923 to 2008, accessible on ECMUB.com at ECMUB.com. National Article 20,713,444 Electrical Code Changes from INS 1923 to INS 2008 provides a historical overview of how electrical codes have evolved. This is valuable for understanding why certain wiring methods are no longer considered acceptable and how safety standards have improved. The NFPA Fire Analysis and Investigation Report, Electrical Wiring, available on the NFPA website at NFPA.org. Public Education Fire Causes and Risks Residential Electrical Incident Case Studies presents case studies of electrical incidents involving various wiring systems. By examining these reports, you can gain insight into the potential hazards associated with older wiring and the importance of proper inspection and maintenance. When working with older electrical systems, safety must be a top priority. Knob and tube wiring, common in older homes, often lacks a grounding conductor, making it more susceptible to electrical shock hazards. BX cable, while offering some mechanical protection, may have insulation that has deteriorated over time, increasing the risk of short circuits and fires. Understanding the materials used in older wiring is crucial. The insulation on older wires can become brittle and crack, exposing the conductors. This is particularly true for rubber-insulated wires, which were commonly used in the early 20th century. Asbestos was also sometimes used as insulation in older electrical equipment. If asbestos is suspected, it is essential to consult with a qualified professional for proper handling and disposal. Grounding is a critical safety feature that may be absent in older electrical systems. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. If the system lacks grounding, it is advisable to install ground fault circuit interrupters or GFCIs to provide an added layer of protection. GFCIs detect small imbalances in current flow and quickly interrupt the circuit, preventing electrical shock. When inspecting older electrical systems, look for signs of damage such as frayed wires, cracked insulation, and loose connections. These issues can create hazards and should be addressed promptly. It is also important to check for overloaded circuits. Overloading occurs when too many devices are connected to a single circuit, causing the wires to overheat. Signs of overloading include frequently tripping circuit breakers or blown fuses, as well as dimming lights when appliances are turned on. If the electrical system is outdated or unsafe, consider upgrading it to meet modern safety standards. This may involve replacing old wiring, installing a new electrical panel, and adding grounding. A qualified electrician can assess the system and recommend the appropriate upgrades. When working on any electrical system, always follow safe work practices. Firstly, turn off the power to the circuit before working on it. Use a voltage tester to verify that the power is off. Secondly, wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Thirdly, never work on electrical systems when you are wet or standing in water. In addition to the resources mentioned earlier, it is also helpful to consult with experienced electricians who have worked with old electrical systems. They can provide valuable insights into the challenges and best practices for dealing with these systems. They can also help you identify potential hazards and recommend appropriate solutions. Building codes and regulations vary depending on the location. It is essential to check with the local authorities to determine the specific requirements for electrical work in your area. These codes may have specific provisions for dealing with older electrical systems. Understanding the historical context of electrical standards is essential for working with older wiring systems. The National Electrical Code, or NEC, which is updated every 3 years, has undergone significant changes over time. By studying older editions of the NEC, you can gain insight into the standards that were in place when the wiring was originally installed. Remember that working with electricity can be dangerous. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician. They have the knowledge, skills, and experience to perform the work safely and effectively. By utilizing the resources mentioned and following safe work practices, you can gain a comprehensive understanding of old electrical wiring systems and ensure the safety of yourself and others. The evolution of electrical systems reflects advancements in technology and a growing understanding of safety principles. Early electrical systems often relied on simple wiring methods and limited safety devices. As technology advanced, new wiring methods were developed, such as non-metallic sheath cable, which offered improved safety and ease of installation. The introduction of circuit breakers and ground fault circuit interrupters also significantly enhanced electrical safety. The National Electrical Code has played a crucial role in standardizing electrical practices and promoting safety. The NEC is a comprehensive set of guidelines that covers all aspects of electrical installations, from wiring methods to overcurrent protection. The code is constantly evolving to reflect new technologies and address emerging safety concerns. Understanding the changes in the NEC over time is essential for working with older electrical systems. For example, the NEC has gradually increased the requirements for grounding, recognizing the importance of grounding in preventing electrical shock. The code has also introduced new requirements for arc fault circuit interrupters, or FSIs, which provide protection against electrical fires caused by arcing faults. When evaluating an older electrical system, it is important to consider its capacity. The electrical panel, which is the central distribution point for electricity in a building, may not have enough capacity to meet the demands of modern appliances and electronic devices. If the panel is undersized, it may need to be upgraded to provide sufficient power. It is also important to check the condition of the wiring. Over time, wiring can deteriorate due to age, heat, and moisture. Damaged wiring can create hazards and should be replaced. In some cases, it may be necessary to rewire the entire building to ensure safety and reliability. When upgrading an electrical system, it is important to use high-quality materials and follow best practices. This will help to ensure that the system is safe, reliable, and energy efficient. It is also important to obtain the necessary permits and inspections to ensure that the work complies with local codes and regulations. Proper documentation is essential for maintaining and troubleshooting electrical systems. Keep detailed records of all electrical work, including wiring diagrams, panel schedules, and inspection reports. This documentation will be invaluable for future maintenance and repairs. When troubleshooting electrical problems, start by checking the basics. Make sure that the circuit breakers are not tripped and that the fuses are not blown. Use a voltage tester to verify that power is present at the outlets and fixtures. If you are unable to identify the problem, consult with a qualified electrician. Electrical safety is everyone's responsibility. By following safe work practices and maintaining electrical systems in good condition, you can help to prevent electrical accidents. Educate yourself and others about electrical hazards and the importance of electrical safety. Remember that electricity is a powerful force that must be treated with respect. In the context of Minnesota, the cold winters and humid summers can impact electrical systems. Temperature fluctuations can cause wiring to expand and contract, potentially leading to loose connections. Humidity can also accelerate the corrosion of electrical components. Therefore, regular inspections and maintenance are particularly important in this climate. Consider factors such as ice dams, which can cause water to leak into electrical boxes, creating a shock hazard. Additionally, rodents may seek shelter in electrical panels during the winter, potentially damaging wiring. Take precautions to prevent these issues. Also be aware of the specific regulations regarding electrical work in Minnesota. The state electrical code is based on the National Electrical Code, but there may be local amendments. Check with the Minnesota Department of Labor and Industry for more information. When working on older electrical systems in Minnesota, it is also important to consider the age of the buildings. Many homes and businesses in the state were built before modern electrical codes were in place. These buildings may have outdated wiring systems that require special attention. Be prepared to encounter knob and tube wiring, BX cable, and other obsolete wiring methods. In addition to the resources mentioned earlier, the Minnesota Historical Society may have information on the history of electrical systems in the state. This information can provide valuable context for understanding the challenges of working with older wiring. Remember that electrical work can be dangerous, especially when dealing with older systems. If you are not comfortable working on electrical systems, hire a qualified electrician. They have the knowledge, skills, and experience to perform the work safely and effectively. Consider some of the safety tips that can be implemented. Firstly, always de-energize the circuit before working on it. Secondly, use insulated tools. Thirdly, wear appropriate personal protective equipment. Fourthly, never work alone. Fifthly, if you are unsure about something, ask for help. And lastly, always follow the National Electrical Code and local codes.